Hello, in this video, we're going to explore the pumping lemma. To do this, I've written a simple Python program to emulate how the pumping lemma works. So let's get to it. Let's share my screen with you real fast. Okay, looks good. All right, so one of the languages that we explored in this semester's class was 0 to the m, 1 to the n, such that our m is less than n. To define this, just make it a function. Two parameters, m and n, and it's going to return true if m is less than n and false otherwise. To test the pumping lemma in this case, we use the book definition of it. So we assume L is regular, and we choose a string S in L with pumping length k, such that the cardinality of S is less than or equal to k. In this case, we pick 0 to the k and 1 to the k plus 1. Our cardinality of S equals 2k plus 1. And by the pumping lemma, S is equal to U, V, W, such that U, V to the I, W, is an L for all I greater than 0. And since the V is not equal to 0, meaning it's not empty, and the cardinality of UV is less than or equal to k. So we start off by storing the string that we're going to create as a list. And the reason for that is because we can make use of the Python count function to see how many zeros and ones have been appended. So S simply here is the alphabet, or in this case, the way we can pump them. So it has to pump all zeros first, or we can pump all ones. It's just used for the loop itself. So the first thing we're going to start off with is result, and we're going to just append a 1. So that's given the string. We've given the string 1. That's in our language, and that'll work just fine. So here is the loop of the pumping lemma. We're going to give characters an S, and we're going to start off with 0, then we'll move the 1 afterwards. But we're going to go while we're going to try to pump zeros until we can pump no more. So here it says while our language remains true, we're just going to keep on pumping the character here, which in case it's going to start off being just zeros. It ends up terminating pretty fast. It's gonna append 1 0, realize that 0 1 is not in the language, and return false. That is the basic definition of the pumping lemma. We can't go, and by the way, we can't go any further, because if we go any further, then we have our UV greater than or equal to k, or greater than k, which we can't have. So that's why this works the way it does. And that's about it. I hope it was informative. Take care.